Welcome to this week's OrbusLive. Topic for today is generative AI and being led by first-timer Thorsten, CMO here at Orbus Software, but actually first time in the hot seat with me doing an OrbusLive. So really great to have you here, Thorsten.
Thank you, Nat.
Really interesting topic we're going to discuss. That's certainly something we've all heard about. And if you've not heard about AI, where have you been? I think I read a little something recently which said, if you're already sick about hearing about ChatGPT and AI, then maybe switch off all media for the next 10 years, right? Because this isn't going away, even though I think Italy has made some protests against it and banned it, and Elon Musk wants to put a halt on all AI. But we're here to talk about, I think, the exciting part, because yes, there are a lot of facets to what AI is. And you've certainly, you've blown my mind recently, Thorsten, with your in-depth analysis. So really excited to see you come out and what you're going to share today on it. For me, I mean, just to set the scene before you take over, is I heard AI described like a fridge. So when fridges were brought to market, it was a hugely exciting piece of technology, right? It transformed food production, how we eat, our health, the knock-on effects on, the Medicare and pharma, etc. It really did change state, and that was the fridge itself. And I think it was described that AI is the fridge, but Coca-Cola was the people that monetized of it. It was the brand that was built on how to use the fridge to sell more. And I think that's where on the cusp of seeing what is going to be the big commercialization of AI. Probably not just one thing. There's going to be many Coca-Colas that come out of this. And this is just the start. So that in itself blew my mind when I read that last night. So without further ado, I'm going to hand over to you. I know you have some slides, and I'm going to do my best to keep you on time. Not that I think you like to talk, but we can always do follow-up sessions. I think that's what we've done before. So over to you, Thorsten.
Thanks a lot, Ned, and yeah, welcome. Thanks for your time. I'm happy to offer you today just my perspective on what's going on. As Ned was saying, today it's almost impossible to not read and listen about AI, and in this kind of context, I usually try to find myself an orientation to really answer to myself what's going on, how and why it's going on. And that's actually something I just wanted to share out with you, and maybe start some interesting discussions on this one. So actually starting with what is happening. Yeah? So I will not repeat all the headlines, but actually the kind of the essence that we all read is like, hey, it's GPT-5. It's just one example of the large language models that are currently up in the market. Is that kind of the iPhone moment for AI? Yeah? So we've read about AI the last decade and longer, but it's now kind of this what happened kind of almost 10 years ago when Steve came to the stage. And I think my strong opinion on this one, it's no, it's not. It's actually it's far more. Yeah, so for sure, iPhone changed the way we use mobile phone, but this was at the end just the accumulation of a few very important technical innovation that come together to market back in the time, and were crystallized in this product. Actually, what we've now seeing with AI, there was a quite interesting quote from something we all know, somebody we all know, Bill Gates, a few weeks ago, who's quoted to say, in his lifetime, he only had 2 moments of innovation that really kind of blew him away. And we all know that this man for sure has seen a lot of innovation in his lifetime. The one was some decades ago, the first invention of the graphical user interface, which changed the way we interact with computers in general. And then the second one he quoted when he saw GPT-3, so the predecessor, last year, or the winter last year, passing some human exams. And there was a point where I think it all became that kind of hot and kind of actually kind of exciting, like we experienced in last month, because there was something most of us weren't betting on happening so fast. So actually,
I think I remember your excitement on Teams. Actually, I remember you pinging me at some slightly ungodly hour, saying, "Have you played around with this tool? We need to get the whole team on it." And I remember thinking, I've heard about it, but your enthusiasm, I think, is what kind of spurred us along. And I remember that, leading up into Christmas, and you were playing around with it. And yeah, it's been interesting to even see that journey over the last.
Absolutely, and for me it was the same kind of. So I've seen so many AI advancement innovations in the last years, and I thought, yeah, it's another one. And when I played with it, I think on a travel to London, I was literally blown away. There was pure surprise on my side, which actually led to kind of this session here. And because what I discovered back in there was kind of actually GPT-4, 3 back in the time. GPT-4 right now, just setting the stage what it can do. It does perform on peak human level for a wide range of academic and professional exams. So kind of exams that has been written in the past to pass or not pass human students, both in academic and professional degrees, on a wide variety of fields. GPT-4 right now is literally just passing that on a level that the average human is not doing it. Yeah? So literally the same questions, the same exams. And that was something that nobody kind of actually thought about or kind of assumed that will happen so far. You see here with the green bars that the improvement from the first version 3 to 4. So you see massive improvement already in the last version jump. And this kind of performance, it's and I think the next surprising thing, it's not just in global English, but it's in a wide variety of languages, from kind of popular until kind of very kind of actually kind of far away from English language, where it shows the same performance. And that actually kind of is the thing where we will look into how does it do it actually. And just an example, and most of you will have played around with it, this kind of questions, classical logical quizzes, GPT-4 is answering with correct and sophisticated answers. The same goes for, even if you go to mathematical proof, something most of us kind of hate it, and it is answering in a good and logical, reasonable way. And now with 4, it even goes beyond that. It goes to visual understanding, and it even kind of understands in a way humor, which is usually seen as very, very complicated to model. So when presented this kind of pictures and ask what's funny about it, it gives a correct description of why this picture is actually funny or kind of hilarious. And
that's my sort of humor.
yeah, it is. And actually, humor is, it's usually something that usually is quite elusive for algorithms. And it actually it creates that as a byproduct. The thing is, and that's kind of the different mentality. It does not always produce a correct answer. So usually you assume that computers and the algorithms produce either no answer or the correct answer. Here it's a different approach. It always creates an answer, but it's sometimes wrong. But it's actually now with the green bars, you see it's almost 80% correct, which is a degree to, or an extent that it's actually normal for humans. Yeah, so if human beings are answering to something, it's usually kind of mostly right, but not always. So that's actually what happened. Yeah, so suddenly we have an algorithm, we have a program that delivers that kind of results. And why it's kind of now so immersive in all media, it's because it's about language, and language has been for centuries seen as that's the core human skill and the core human actually capability, which defines reality, and only humans can use it to that extent. And now we're confronted with a tool, an algorithm that uses language in a variety of degrees to a human or even peak human kind of skill level. And that's just a question. So how does it happen, and what do we do with that? And actually, first of all, to how. So how does it do it? There was my question. So my background is computer science, and I thought, why? I cannot explain why actually it reaches that kind of level. And here it's just a little bit of kind of context for most of you know it, but I think it's important to see where we are coming from. human beings are learning in two different ways. So for either you understand and rules and concepts and understand the rules of a game and play it, or you imitate something. Like children are looking at other children and seeing what they're doing and just imitating the pattern and behavior. Both are the two very different ways of learning. And actually, in this kind of tradition, AI, which is around now since almost 70 years, has been following the two very different paths. So creating modelings for thinking, for conceptions, or to kind of do training-based approximation of human behavior or kind of intelligent behavior. And in this kind of two different things are, I think, tangible in games, classical board games. There was one when I was always almost a teenage boy in this kind, when the first time the best world chess player Kasparov was beaten by computer. It's quite long ago actually already. It's 97. So there was a time where computer algorithms.
Feel old.
Yeah. I feel
that long ago.
Yeah, I was 23, 24, I think 23. So back at the time. Yeah, so there was kind of the first kind of breakthrough of AI. Deep Blue, IBM back in the time created an algorithm who could beat Kasparov on chess. It did it by brute force, so learning the rules and literally kind of going through every possible combination and just estimating what is the best move. So there was kind of the left kind of thing of learning, so understanding the rules and concepts and doing literally just brute force calculation. After chess was kind of solved, it went over to Go. Go was a board game that was similar, but very, very, very much more complex. So much more complex that it was never possible to do the same approach, so to calculate everything. And for this one, it took a while. So that's very much more recent when this happened. So Licido in almost less than a decade ago was beaten by AlphaGo by Google with a mixture of the two elements. So both classical algorithm and modeling and first time in kind of neural networks, so kind of an behavior matching, pattern matching algorithm, and the combination of both actually solved this problem to beat the human player in Go without actually fully understanding Go in this way. So kind of combining it. So there was kind of the last board game that was kind of solved. So AI moved away from this one. And actually this concept of neural network, which was used to solve Go, not going deep, but it's a very simple kind of thing. Like you're giving some input parameters, you're calculating layer by layer by layer through simple calculations, like neural cells in your brain, and you're getting one output vector or thing. So it's nothing very, very special in terms of complexity about this, but this kind of principle is actually what GPT-4 is built on. So it's a big neural network actually.
Can I ask?
Sure.
I mean, we reference ChatGPT here before, but is things like Bard kind of built in the same way? Are they all kind of built out in the same process and methodology of thinking? So is it interchangeable? Sorry, that was this one.
No, absolutely. We just used GPT-4 here because it was kind of the first in the press on this one. The models on Bard or Alpaca are all kind of large language models. So the same kind of transformer-based neural networks, which all they're kind of different kind of speciality, but actually kind of the conceptual thing. It's all neural networks, large neural networks. So you can translate most of the things here to the other ones. So the interesting piece here, it's literally how from this very simple thing, giving an input and getting one output, how can create language and then kind of a text. And this is literally as simple as that. You give some input text, some whatever. A chat prompt is nothing else than an input text. And then the algorithm calculates the next fitting word, the best fitting word, one word at a time, and then take the input plus the word again in the algorithm and calculates the next word. So it's literally like if you're thinking while you're speaking and always kind of just thinking to the next word. Yeah, and it does this until it reaches kind of a limit, or kind of like there is not a next probable word. So that's actually how the algorithm works. And that's why actually you can create language with such a network. That was for me the first revelation. Wow, it's that simple, literally just creating one word at a time, which is a total different thing. Like in the past we did language, and in the past, if you look at translation, whatever, you try to get the whole kind of answer, try to find a semantic kind of core, and then creating language. But here it's literally just one word after each other.
So I heard yesterday someone use the example of what would you expect when you say peanut butter and jelly, right? That was sorry, my brain was. So it learns that the most commonly when you say peanut butter, and it will learn that jelly would be the most common word next. Is that what you mean in sort of basic sense? Is learning that progression?
Actually, it is that. The basic concept of the algorithm is that simple, as you said. Yeah, you input some words and say what's the next logical word. The only question now is, why is the output any reasonable kind of text? Why is it not just kind of gibberish? Yeah, because that's actually what you would expect, that the next possible word is like jelly, and you never get even a kind of correct grammar after that one. But you, from ChatGPT, you get a full new proof. How actually could that happen? So that this simple thing, just getting the next word, give you some correct language. And actually that's the magic, and that's mostly a discovery than an invention. So it was really kind of, this algorithm was built, and it created surprisingly well results that were kind of refined. So nobody could really expect from this to get the answer. That's the first learning. It was not actually kind of designed to create that, but actually it was a discovery that this algorithm will give you this quality if you do certain things. And the certain things, and that's really kind of the why. What are the key factors why actually it works? And this, I broke it down to a very kind of few things. First is the concept of tokens. I saw on the slide that it creates kind of one word at the time. That's not totally correct. It creates one token at a time. And the difference between a token and a word, token is kind of a sub-word. So a piece of a word. And here you see as an example how GPT tokenized this sentence. In the color before, you see code base, for example, is split down to code and base. And interestingly, the word over-Pythonized doesn't exist, in Webster, but it's kind of artificial word that somebody just created by just combining the language Python and then iced as kind of kind of the grammar for, and then over. And actually kind of by having tokens that could be kind of created in this way, GPT is kind of just capable to create new words, or kind of this kind of combination of words, and actually kind of create output in all languages. Because by this kind of tokens, you can combine most of the common languages you have. And it's roughly 50,000 tokens, which are the Lego blocks of building most of the human language together, and in just puzzling this together. So what it actually does, it takes an input text and creates the probabilities for each of the 50,000 tokens. So which of the 50,000 tokens, or 48, is the most probable one for the next step? So that's actually what it does. And one other thing that it does is it randomizes it a little bit. So it doesn't give you always the most probable, but kind of it randomly takes one of the most probable. And it's a parameter, it's called temperature, which chooses how creative it is. So sometimes it gives you the 10th most probable thing. So that's why you always get different answers if you do the same. So here it's kind of this randomized, the creativity comes in here. And that's the first thing. So it uses tokens instead of words, and by this it can actually kind of combine most of the language we use. First thing. Second thing is size. And size on this one means, if you remember this kind of picture of a neural network, how many of these nodes it has. Yeah, so actually how many calculation it does. And actually quite a lot. So it's kind of 175 billion parameters. So if you look at this kind of calculation in this network, for each token that it outputs, it's doing 175 billion calculations, which is quite a lot. So even if you input what is 5 plus 5, it needs to do 175 billion calculations to get the output. So it's not very efficient compared to a calculator. So it's really massive in terms of kind of things it's doing. So that's the first thing, and that's very, very much more than any model we did 10 years ago. So if you compare it to AlphaGo or whatever, that's a factor of millions more than AlphaGo at the time. So size, that's the first thing. And if you compare to the human brain, which is for sure just an approximation, it has just the human brain 1,000 times more parameters than GPT-4, which is actually kind of impressive. So it's much smaller than the human brain, but not million times smaller. So it's really big. Third thing is actually what is used to train this. Because in neural network, the key thing is you don't define the parameters out of any model or something like that, but you let the model define or learn the parameters themselves. So each of this 175 billion parameter has been trained, has been found out, actually, based on some input data, some training data. And the training tokens has been used, it's more than 500 billion training tokens. So almost 1 trillion training tokens. And how big is that? So for sure big. But compared to this one, it's the whole internet. So literally common crawl means the whole available text information in the net. The whole Wikipedia in all languages, which is only kind of 3 billion tokens. Kind of common sets of books, so which is almost kind of 10% of all the books that ever has been printed in human history. So it's actually quite a big chunk of all printed or textual knowledge that humanity has digitalized so far, that has been used to train this model. And I think that's something we should digest, or we need to digest. So it just gets the most probable kind of next token, but it's built on literally every text that has been digitally been written in the so far. So it uses Shakespeare's Hamlet. So what did Hamlet said? Everything it's kind of built in this model has learned. And if you've compared the parameter size and the training size is quite the same. 175 billion, 500 billion. So almost all the information of this text is it's available in the model in a different form. So nobody knows literally how, but it's actually in there. So if you chat with GPT, you're chatting actually with the whole text that humanity has been produced so far digitally. And I think that's the key thing that you have to digest to get a feeling. And then kind of based on this kind of really brute force size, has been a process of fine-tuning. That means a lot of real human beings has been interacting with chat or with GPT, getting answers to prompts they're giving, and then kind of reviewing and saying, hey, it's a good answer, it's a bad answer, and kind of fine-tuning that. And even kind of learning a smaller model to act like human kind of fine-tuners so that it can self-tune itself. And this process actually on having the whole internet as a training data and then use some thousand human beings on kind of fine-tuning that led to this actually very, very accurate output quality that we see. So that's actually kind of size in both data and kind of human fine-tuning. And the last piece, actually, what most of you who are kind of in computer science will kind of see as kind of astonishing or kind of a paradigm change. There's always a difference between code and data. Yeah. So what has been coded into something, what a model can do. And here, if you say code like summarize text, give a text, or kind of giving the text, please summarize the following text, in this model, it's actually the same. So that means that you don't have to program what the model can do, but you can just ask it what it can do. Yeah, so many of the function has never been, or none of them has been programmed, but it's kind of just an output of the language itself. And that's kind of the key thing that everybody kind of just realizing. Coming to the end, actually, kind of just 2 or 3 minutes left. One of the kind of question in the media is like, it's AI becoming human-like, and do we see Steiner taking over the world and all that stuff? The clear answer, no, we don't see that at all.
Well, not what I read last night. Like conspiracy theorists and ideas.
I know it, and the problem is that it looks like it, and it's very kind of similar to it. The key thing is, and that's always going back to fundamentals. We know how it's built. It has no long-term memory. It has no agency. It has no introspective. It has no body experience. So actually, the question, what would a human being without a body being? It's an empty one, because there hasn't ever been a human being without a body. And so actually here, the first thing is, no, that's kind of science fiction. That's a very different thing. The real thing actually is what we learned, what we discovered right now. Human language seems much less complex than we expected. And so it's becoming obvious that you can create human language to a degree without understanding the language itself, without feeling the emotions. You can actually kind of.
I was about to say the semiotics, the language that's not spoken when you have the words.
Absolutely. Right? And this is kind of, if you compare to professional acting, there are the two schools of acting. The ones who are kind of feeling and expressing, and the other one who is kind of acting abstractly. And here we just see with human language, actually both is possible. Yeah. So you can act without feel. Yeah, so you can create language, you can speak without understanding and feeling. There was something we, until now we thought it's not possible, or we assumed it's clearly possible. Yeah. So, and I think that's a key learning. It's not AI; it's getting so much more intelligent than we thought. We just learned a new thing about language. Yeah. And actually take it from there. So first of all, I would say let's stay to the fundamentals and facts, not worry about so much about Skynet, but actually more like. That is something now which is really kind of once in a generation, I think, situation, because it's now all about exploration discoveries. Nobody, even the creators of the models, don't know what they can do. Both in negative, but in a positive thing as well. So there could be use cases, there could be kind of discoveries that, actually I can discover first. So it's kind of an very democratic thing. So it's not like
wasn't it set up, the founders actually, as almost a non-for-profit, or it was kind of not based for making money, because they wanted it to be available for everyone to discover and explore it all.
Absolutely. Well. And for sure there's a lot of commercial interest and everything on it. Still, this is first time again where the playing field is very much kind of leveled, because the only interface you need to use that tool, and it's human language. It's a core thing that we need. You don't need to learn any kind of API, whatever. And that's kind of my first thing. I would like to encourage everybody to really say, hey, let's dive deep and kind of discover and explore. So everybody is starting from the same point now.
So I am conscious of time, and I've got a couple of things I just want to throw at you, which so we've already got a question from a regular in the chat regarding the sustainability approach to using it and what it takes. I think there's some stats about the volume of liters of water that was used to cool the data center in order to produce this intelligence. It's an interesting one, right? Because this is an avenue for discovery to enhance us as well. It can be for a force of good, but obviously there's always checks and balances that need to be in place, and we need to progress this information in a sustainable way. I mean, I just got off a call with someone that actually talked about ESG and AI in the same thing. They're like, one will support the other. They're intrinsically linked. How do we ensure a positive impact and change for the planet? AI can probably help us with that, or speed it up to help us get to that good. I guess there's always going to be trade-offs, I guess, is what I'm coming to with that question. And it's a great question. Thank you.
No, absolutely. And I think that's a key thing to mention when I make the kind of example of just using it to do kind of 2 + 2. It's a very, very, very efficient way to do it. So here, at the moment, so it's nothing we can just get for free. That's actually kind of why ChatGPT has a cost attached to it. So it's good to explore, but it's nothing we should waste. There should always be kind of a price applied to it because it doesn't come for free. There's a data center running it. So I think here that's a key thing, not to waste resource. I think now discovery exploration for sure, but not kind of integrating it for free in everything because it will be damn inefficient.
And I wouldn't be a good marketeer if I didn't lead this back to Orbus Infinity, Thorsten. And I know we have a lot of people online who are keen to understand what it is we're doing, not only as humans and workers within the business and discovering, but with Orbus Infinity. Anything you can leave us with as a hook or something that's going on for us at Orbus Software?
Absolutely. So I think here Orbus Infinity is all about decision intelligence. It's about helping organizations to do the best decisions, and actually decisions always are expressed in language. It's like what to do. So it has kind of a very, very deep and direct connection to what I talked here. So we are working very actively to surface these new capabilities in all points of the platform. So imagine you could interact with kind of diagrams, not by looking at but by asking like, hey, what's the most important decision I have to take? What are the applications I should retire first? Imagine you can just chat it down and not have to read kind of complex diagrams. Imagine you could get recommendations for kind of strategies out of that. Imagine you could get plans, you could get roadmaps, you can get second views on something, all expressed in natural language in all languages you want. That's now very much in our grasp. And then this is actually what our product team is now working with a lot of energy and actually kind of excitement to see what are the use cases, what are the things we can now express in a totally new way. And yeah, we'll see a lot of that. And I hope I see a lot of you or some of you in our next physical events in London, New York, to maybe share a little bit more on this one. And be sure that here online you will see quite of interesting innovation coming. So looking forward to it.
We do have another question that's come in the chat here, sure. Which is, can enterprises build their own GPT to train it with their own data?
So actually, all of the kind of big vendors on this one are offering kind of custom models, so that you can train or kind of retrain the models with your own data sets in many ways, either kind of training neural networks or using like plug-in APIs like GPT's offering. And for sure that's actually the way how you can do it. So there, either you're doing prompt insertion, so you're putting your own data into the prompt, you're training kind of the model yourself, or you're adding an API. In all the three ways, you get your own private data actually kind of infused to these algorithms. And yeah, for sure that's the way enterprise will have to do it.
So thank you for answering that one. So you're basically saying watch this space with Orbus Infinity and what's to come with AI. And annoyingly, you're not putting a date in. That's okay. Classic. And we can keep the conversation going over the course and maybe get you in for another series.
Happy to do so. And just thank you for hosting this today. Thank you for listening, for your time, to everybody out there. And just let me end with with all the new things are coming and are actually there. Let's kind of get back and kind of re-emphasize what makes us kind of humans and what are the key things. And that's actually kind of very much the same that we've been taught in school and kind of been learned from our elders. Be curious, ask the right questions, and challenge the answers. That's exactly how you discover what's in there. And on this one, I'm ending on a very positive note, because that's kind of what's makes us human. It's not so much the language itself, but actually doing this, being curious, asking the right questions, and understanding the answers, challenging the answers. And let's stay true to this. And
no,
going
thank
to
you very much. I think we might need to get you back, Dawson. All right, thank you so much. Have a lovely for everyone who joined. Speak to you soon.
Thank you. Speak to you soon. Thank you. Bye-bye.